Now, in this video, we will going to take up the projections of laminas. So we're going to give you the introduction. What is lamina, how they have been classified, and what are all the various positions. And to analyze how by keeping the lamina in different positions, how the lamina will going to look like. A lamina is a sheet. So that means it has only the surface area and having unit thickness. Let us see that when you go to the next slide. So the lamina can be classified according to the shape. What does it mean? There are various different shapes of a polygon. One, it may be a triangle. A triangle will going to have three sides. Then we're going to have a rectangle, wherein the length and breadth, two opposite length and two opposite breadths. Then it should be a square. Then it should be a pentagon. Then hexagon. Of course, you can have a heptagon, octagon, decagon, all those things. But according to our syllabus, we have from triangle to hexagon. And then lastly, we are going to have a circle. Then comes with the various positions. How in this, actually in the lamina, what we are trying to study is how the lamina will going to be placed in different positions. That means when you are placed parallel to HP, how the lamina will going to look like, whether it is on the edge or it on the corner, or when it is surface is inclined to HP, or the surface is inclined to VP. All those things which will going to be studied in this. So what are the various positions initially? So one way is lamina is parallel to HP. Once the lamina is parallel to HP, obviously that lamina has to be perpendicular to VP. Once the lamina is parallel to VP, obviously it should be perpendicular to HP. So then the lamina is inclined to both HP and VP. Then it is perpendicular to the profile plane. Now let us see how this will going to work. So first we have the concept of lamina parallel to HP and perpendicular to VP. So when you are considering this, so we can see the lamina is parallel to HP and perpendicular to VP. So when you look from the front view, you can see the lamina is parallel to HP because all the sides of the lamina are on horizontal plane. So it means the lamina is parallel to HP. So when you look from the front view, we can see A dash, B dash. So when you look from the front view, AB is near to the observer, so A dash and B dash is visible. And then C and D is away from the observer, so C dash and D dash will be in bracket. So the line, all the sides are on HP, so line is parallel to HP. So when you look from the top view, what happens? The shape of this square lamina is a square. Why? Because when all the sides are equal, so that means AB is equal to BC is equal to CD is equal to DA. So when you look from the top view, we can see ABCD is a square. So how do I know that it is the true shape? We know that A dash B dash is parallel to HP. So obviously you're going to get the true length in HP. B dash C dash is parallel to HP. So obviously you should know the true length in HP, BC. Then C dash D dash is parallel to HP. So obviously CD is in true length. And D dash A dash is parallel to HP. So DA is in true length. So obviously all the sides are parallel to HP. Therefore you are getting the true shape here. So hence the surface is parallel to HP. Now here the shape of the lamina is seen and the two sides are. So here what we can see, AB is parallel to VP because two endpoints of A and B is both are at equidistance from the vertical plane. BC is perpendicular to HP or perpendicular to VP and parallel to HP. So BC. CD is again parallel to both HP and VP, and AD is again parallel to HP and perpendicular to VP. So AB, BC, CD and AD. The point A and B is nearer to the observer front view, hence it is visible in the front view. So that is what I told. Therefore, A dash and B dash are in without brackets, and whereas C dash and D dash are away from the front view, hence it is invisible. So we got this. Since the surface of the lamina is perpendicular to VP, therefore you are getting a line in the vertical plane. So all the sides are parallel to HP. So when you look from the front view, we can see all the sides are parallel to HP because all the sides are right on the XY line. So obviously it will be the parallel to HP. Therefore, in the top view, you are getting the true length. So since the shape is a square, therefore you are going to get it as a true shape. Now when you want to rotate this, that is like what we did in our projections of points in the front first quadrant, rotate HP down, then what happens? The top view will come down and the front view will go to the vertical plane, the XY line. So A and B is near to the observer, so A dash B dash is visible. C and D is away from the observer, therefore C dash D dash is invisible. When you look from the top view, all the sides are looking from the top view is visible, so therefore ABCD is visible. Since all the sides are parallel to HP, so we are getting the true length. So this is how we can analyze the lamina which is parallel to HP and perpendicular to VP. Now we go for the one more example. The lamina is parallel to VP and perpendicular to HP. How is it going to look like? So here, when you look from the top view, the lamina is parallel to VP. When you look from the top view, we can see all the sides are resting. All the sides are parallel to VP. All the sides are parallel to VP. Therefore, you can see. So when you look from the top view, all the sides are parallel to VP. Where I can see that? I can see in the horizontal plane. We can see here AB, BC, CD and DA. All the sides are parallel to VP. Therefore, you are getting the true shape in VP. That means A dash B dash, B dash C dash, C dash D dash and D dash A dash are in true length. Since the shape is a square, you are getting the square true shape. So when you are analyzing individually, this individually, since it is perpendicular to VP, you are getting the line in horizontal plane. When you look from the front view, we can see that A dash, B dash, B dash, C dash, C dash, D dash and D dash, A dash all are visible. Therefore, you are getting the true shape here. That is A dash, B dash is 100, B dash, C dash is 100, C dash, D dash is 100 and D dash, A dash is 100. So therefore, you are going to get a square of 100 mm side. So when the front view, the point A dash and B dash is near to the observer. So that means when you look from the top view, hence it is visible in the top view AB. Therefore, A and B are in without brackets, and whereas C and D are is away from the observer, so therefore it becomes invisible. Since all the sides are parallel to VP when you look from the top view, therefore in the front view it will be in true length. So you can see the shape is in true length. But this is in the 3D sketch. But when you want to rotate this and make it, when you rotate the HP down, so what happens? So HP will going to come down, but VP will be there only. The square shape will going to be in the front view, and since the line is perpendicular to HP, so obviously in HP you are going to get a line. There it was line is parallel to VP and line is parallel to HP and perpendicular to VP. Therefore, in VP you are getting the line. But in this case, it is perpendicular to HP. Therefore, in HP, you will going to get a line. So that is only the basic difference. Now, when you are considering the line which is inclined to both HP and VP, obviously that will be perpendicular to the profile plane. So, when the lamina is inclined to both HP and VP, then the lamina is always perpendicular to the profile plane. That is, the end capital AB is on HP and the end CD is on vertical plane. You can see this here. So, when you look from the left side view, you can see the line is inclined to VP and also the line is inclined to HP. Since it is perpendicular, that is 90 degrees to the profile plane, obviously you are getting a line here in the profile plane. So when you look from the front view, the end AB is on HP. So A dash B dash is on XY line, while the end C dash D dash will be on VP. So join A dash B dash C dash D dash, it becomes a surface. Both B dash and C dash and A dash D dash is appear to be perpendicular to HP, but A dash and C dash D dash will be parallel to HP. A dash B dash and C dash D dash are parallel to HP, but whereas AD and BC are appears to be perpendicular to HP, because actually A dash D dash, that means you can see A dash D double dash is inclined to HP, that you can see here also it is inclined to HP. I mean, it is inclined to both HP and VP, and similarly BC also, which is appears to be inclined to, I mean, which is actually inclined to both HP and VP. When you take the top view, both the end capital AB and CD is parallel to VP now. When you look from the top view, both AB and CD is parallel to VP, and the end CD is on VP. The end CD is on vertical plane. Therefore, the end CD is on XY line in the top view, while the end AB is away from the vertical plane. You can see here, away from VP. Join ABCD, it becomes a surface. Both BC and AD, both BC and AD, both BC and CD appears to be perpendicular to VP. But again, that is only the reason, because it is inclined to both HP and VP. But AB and CD is parallel to VP. When you are considering the left side view, since the surface is perpendicular to right profile plane, hence a line will be seen in right profile plane. The image is on RPP, it is a left side view. I am looking from this direction and writing the view here. So that means we are going by the first angle projection, because the projection what we are considering here is on the first quadrant. Now obviously how it will going to be formed when you are looking in the first 2D sketch. So when you cut this vertical plane, when you are cutting this here and rotate HP down and RPP towards the right side, see how it will going to look like. That is VP, HP and RPP. So you get A dash B dash, B dash C dash, C dash D dash and D dash A dash, and this is AB, CD and DC and AD. So here, how do I know that here A dash, so here A dash B dash is on XY line. You can see A double dash B double dash is on HP and D double dash C double dash is on VP. So when you look from the left side view, A dash and D dash is near to the observer. So A double dash and D double dash is visible, and B dash and C dash, which is away from the observer. So B double dash and C double dash is invisible. We can see here CD is on VP. So obviously D double dash C double dash is on the X1Y1 line, and AB is away from VP. So you can see from here this distance is away from vertical plane. So this is how we will be able to analyze this problem in 2D sketch. Also the same thing what we have written here, except that we have not shown any dimensions. This is the surface which is inclined to HP here, and this is the surface which is inclined to VP here, and the surface still perpendicular to profile plane. So that is the reason why you are getting the line. When the surface, please remember, when the surface is inclined to both HP and VP, obviously that surface will be perpendicular to the profile plane, and only in the profile plane you will be able to see the surface inclinations. Otherwise, it is not possible to see in vertical plane or in horizontal plane. And this is how you will be able to analyze the projections of lamina. That is basic introduction on projections of lamina. Thank you.